So in this lesson, we are going to talk about series and how do we condense the series and how do we expand it. So the series is when the terms of sequence are added together. So when you have terms of sequence, and when you add them, that gives you a series. So this can be a finite series and infinite. So for finite, the number of terms are countable. So number of terms are countable here, and here the number of terms are uncountable. So first of all, it's just the terms of the sequence which is added that will give you a series. So the example of the finite series will be 7 plus 5 plus 3 plus 1 plus -1 and plus -3. So this is finite because it stops and there are 1, 2, 3, 4, 5, 6 terms in this series. The infinite one will be 10 plus 8, for example, 6 plus 4, and then it keep on going. So this is the infinite series where number of terms are not countable. Now the series can be written using a sigma notation. So we can condense it using sigma notation. Now sigma notation is, sigma is a Greek letter, and we use that for condensing the series. So for example, when you have 3n minus 2 and then there is a summation here, and let's say n is equal to 1 to 5. So this sigma, this is called sigma. So this is sigma or summation notation, and 3n minus 2 is the rule for the sequence. Now the sequence can be any kind of sequence. So as long as you can find a rule of that sequence, so that rule goes here, and then this is called the lower limit and this one is the upper limit. So from here I can see that this is a finite series and there are 5 terms. So starting from n is equal to 1, so if I will substitute n is equal to 1 in this rule, it will give me the first term of the series. And the role of summation is you keep on adding plus. So there are 5 terms, so 1 plus second, third, and then fourth, and then you have 5th term. So for this term, your n is equal to 1. So you start with the lower limit. So 3 times 1 minus 2. So 3 times 1 minus 2, that is negative. 3 minus 2, that is 1. Then you have 3 times 2 minus 2. So that's 4. And then 3 times 3 minus 2. 3 times 4 minus 2. 3 times 5 minus 2. So this is how you will get all of your terms of this series. And in this case, if you find out this is 7, so in this case this series is an arithmetic series because there is a common difference here. So this is arithmetic series, but it's not always required that all the series will be an arithmetic series. It could be any kind of a sequence, and then when you put them with the addition sign, then you will get a series. But in this case, the rule 3n minus 2 generates the first 5 terms of this arithmetic series. Okay. Now I'm going to do a couple of examples to see that in the previous one, when I explained the previous one, there the rule was given and you were finding the 5 terms of that series. But here again it's similar. This one is again similar. There is a summation notation. The rule is given, and then you have to find the number of terms here. Again, express that as a series. So here you can see that n is equal to 1 to 4. So what happens here is, so you start with n is equal to 1. It's a finite series again. So this is finite. So you start with n is equal to 1. So you substitute -1, 1, 1 square, -2, 2, 2 square, -3. No, sorry, this is -1. This is -1 to the power of 3 because n is changing only. So 3 square plus -1 to the power of 4 and then 4 square. So there are only 4 terms and it's a finite series. So here this is negative, which means one term will be negative, one positive, and so on. So this is 1. This will be -4. This is going to be -9 and this is going to be So this will be, sorry, this is going to be plus, this is minus, this is plus, then minus, and then you have plus 16 here. So one negative, one positive term here. So this is how you can expand when the series is given as a summation notation. So you can expand it starting with substituting the lower limit and then stop when you get to the upper limit of this summation. Now here, and in these examples, so sometimes they ask you to expand it. So that could be the question could end there. Or here they also ask you evaluate. Evaluate means you find out the final answer here. So it's a evaluation. Evaluate means a numerical answer. So you need to find a answer which is a number, so numerical answer here. So now here you have -1 plus 4, so this gives you 3. 3 minus 9, -6 plus 6 is equal to, so you will get your answer here, that's equal to 10. If they ask you to evaluate, then that's what you need to do here. So similarly here, so be careful, because in the previous example your lower limit was 1, so pay attention to the limits which you have for summation notation. So here n starts from 3, so that means you start with -2 to the power of 3, plus is because of this summation symbol, and then you have -2 to the power of 4, -2 to the power of 5, -2 to the power of 6, and -2 to the power of 7. So how many terms you have here? 1, 2, 3, 4, 5. So number of terms you have here is 5. And the another thing, the easier way to find out how many terms before you expand is you look at the upper limit, which is 7 minus 3, that gives you 4, but number of terms is 5. So you always add 1, which is 5. So if you have, if I ask you how many numbers you have from 1, 2, 3 to 10, then there are 10 numbers here. So to find out how many numbers you have, you always can do 10 minus 1, which is 9, and then you add 1. So that gives you 10. Okay, so the number of terms here is 5, and now you simplify it, you open this bracket, and then you will find, if they ask you evaluate, you find a numerical answer here. The next one is, now here how many terms we have? We have 3 terms here. Similar question. The only advice I will give in this question is that this general rule consists of more than 1 terms. So the first thing which you should do is you should put a bracket here. So even if the bracket or the parenthesis is not given, so that should be your first start. So now n is equal to 1. So 2 times 1 minus 1 square plus 2 times 2 minus 2 square plus 2 times 3 minus 3 square. And then this is equal to 2 minus 1 is 1. This is 0. And then this is equal to -3, and then you will get -2 if they ask you to evaluate this. Then next one is -3 plus 5. Now this example is different than your previous one. Here you have series given. We don't know whether it's an arithmetic series or not, or as I said, it can be any kind of series. And what you need to do is you need to identify the pattern and then condense it using a sigma notation. So that's what they're asking you to do in this question. So using sigma notation, you need to condense this. So first, one thing you can start is starting with summation notation, and then how many terms we have? 1, 2, 3, 4, 5. So n start from 1 to 5. So we have 5 terms, and let's say n start from 1. Now we need to look at what kind of sequence or what kind of series we have here. So if you look at, let's try to find if we can see a pattern here. So -3, 5, 13. So if I add 8 in this, so I will get 5. So it looks like this is the arithmetic. This is arithmetic sequence. So why I'm saying it's sequence? So I'm talking about numbers only. This is a series, but to find the rule, if I write down this as arithmetic sequence, then I can see here there is a common difference of 8, which means for this one, we know how to find the rule. So the rule for this one is going to be un is equal to u1 plus n minus 1 into d, and u1 is -3, and you have n minus 1, you will have n here, and 8. So negative 3 plus 8n minus 8. So that gives you 8n minus 11. So 8n minus 11. And now we can substitute to check. Let's substitute n is 2. 8 times 2 is 16 minus 11 is 5. So second term is 5. 8 times 3 is 24 minus 11. That gives you 13. So this is how you can change a series into a sigma notation. Now, the next one is negative 3 plus 6, negative 12 plus 24. So first thing, your n start from 1 to 4, and now we need to find out the rule here. Now here you can see that one term is negative, one is positive, then negative, then positive, which means you will always have here negative 1 to the power. Now the first term is negative, which means it will be n here. So if n is odd, this will be a negative terms. If n is even, this gives you the positive term. Now the pattern is quite simple here. It's not an arithmetic, but you can see 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24 if you ignore the sign here, because we already took into account this sign. So 3 times 2, which means if I want, so this is basically 3 times 1, this is 3 times 2, this 12 is 3 times 4, and then you have 24, which is 3 times 8. Now we need to find out the rule for this one. So this can be, I can see 3 is common, so 3 will be here, and then this is your u1, this is u2, this is u3, this is u4. So this can be written as, this you can write 3 times 2 to the power of 3. This can be written as 3 times 2 to the power of 2. And this can be written as 3 into 2 to the power of 1. And this can be written as 3 into 2 to the power of 0. So if you have first term, you have exponent or power as 0. So here you have 2, 1 less. Here you have 3, 1 less. Here you have 4, 1 less, which means for un, you are going to have 3 times 2 to the power of n minus 1. So I'm just going to rewrite it. So I'm going to write here 3, and then you can have minus 1 to the power of n, 2 to the power of n minus 1. You can also write this 3 out of the summation, because this is independent of n. So you can also express this in this way. Okay. So 3 is multiplied by this. Okay, let me rewrite this. So 3 is here. Okay, so you can also do that. So you can expand this, and then you can multiply each and every term by 3 at the end. Or you can keep this 3 here, and then you keep on substituting. But it's better to keep 3 outside, because then you don't have to keep on multiplying with 3. Here you may not have that big number, but if you have very big base, then it's better to take this 3 out of the summation notation. Now next one we are going to do here is, as you can see, this keep on going, which means n start from 1 and it goes all the way up to infinity. So for infinite, we don't know what is the maximum number we have here, so you will have infinity here. Now again the same thing, I'm going to rewrite this as a sequence to see what is the pattern here. So here you have plus 4, and plus 4, which means it's an arithmetic series. So for arithmetic, we know that un is equal to u1 plus n minus 1 into d. So you need a rule here. And u1 in this case is 8, n minus 1 into 4. And when you open it, this is 4n plus 4. So you get 4n plus 4. I will highly recommend you to use the bracket here, so that you know that when you substitute n is equal to 1, then you have 4 plus 4, which is 8. And when n is 2, you get 4 into 2 is 8 plus 4, 12, and so on. But it will go, it's an infinite series. Okay.